I'm David Martin. I'm the CEO and chairman of a small biotech company in South San Francisco called Avidbiotics. And we're focused primarily on bacterial diseases and trying to influence the management of bacterial infections, mostly by prevention, but also treatment, using a quite novel technology that is actually an exploitation of what nature has been doing for probably 500 million years. Well, as you may well know, many people are aware of, bacteria are competing with each other constantly. And so there's a bacterial warfare going on, and they use different weapons. One of the weapons they use are what are referred to as R-type bacteriocins. And these are nanomachines, if you will, that bacteria can produce when they're stressed. And these nanomachines can bind to other bacteria, that is the barbarians, and punch a hole in the envelope of the bacteria, killing it quite instantly. So what we have done is discovered and invented a technology, a proprietary technology that allows us to retarget these bacteriocins so we can kill the bugs that we want them to kill rather than the bugs that the producing bacteria would like for them to kill. And we call these avidicins for human application, or puricins for use outside of human applications, such as in food safety or animal health. Well, C. difficile, as the CDC has described at the end of last year, is a major threat, one of the three major threats to the health of the American population. C. difficile is now the most frequent hospital-based infection in North America and in many other parts of the developed world. We have developed one of these R-type bacteriocins that specifically kills Clostridium difficile in the gut. It's orally active in mice. We are in the preclinical phase of development, and the intent is to use these agents, which we refer to as difficins, to prevent the colonization of the gut by this bacterium, and or for those individuals who exist without symptoms but are carriers of Clostridium difficile, to prevent those bacteria from expanding when those patients are put on antibiotics that kill the other bugs in the gut, and to prevent the consequential severe diarrhea with high morbidity and a pretty threatening mortality, particularly to older patients, that is those who are over 50 and are exposed to antibiotics, which allow C. difficile to flourish and present toxins and to create severe colitis, megacolon, et cetera. And E. coli is a much earlier product for humans. We do have a collaborative program with DuPont targeting E. coli, Salmonella, and Listeria in food safety to prevent the foodborne illnesses caused by those organisms, including E. coli, like E. coli O15787. Our human application there is to prevent recurrent urinary tract infections. E. coli are normally a minor component of the gut bacteria, or the bacterial community in the gut, which we call the microbiota. But some of those E. coli, while they cause no problem in the gut, they do cause a problem when they get into the urinary tract, such as in the urinary bladder or into the drainage system of the kidney. So our project there is to kill specifically the E. coli in the gut and in the vagina that are asymptomatic, that is, cause no problems in those organs, but when they get into the urinary tract, they do. And the idea is to kill them using these bacteriocins, these R-type bacteriocins, administered orally to patients who are carrying these organisms to eliminate them from the reservoir from which they escape and then enter to cause urinary tract infections. We're very much aware of what those issues are. I think that to eliminate an organism like Clostridium difficile from the gut or a uropathogenic E. coli from the gut, it's fairly straightforward to demonstrate efficacy and safety. That is, both of these organisms can be cultured from feces, so one can monitor the presence or absence of these bacteria before and after treatment, different doses of treatment, et cetera. So I think that's fairly easy in terms of how does one demonstrate efficacy. The safety is similarly very straightforward with the types of agents we're using because they are extremely narrow spectrum. They're highly targeted. And we've shown in experimental animals that they do not damage the healthy microbial community in the gut. So I think in that case, it's relatively straightforward. If there's a known pathogenic bacteria, then one simply demonstrates that it can be eliminated or at least reduced in its density, and one can show safety by demonstrating that there's no unintended collateral damage to the healthy microbial community of either the gut or the vagina. That's easy. What's going to be difficult, I think, is when we delineate or validate the relationship between a bacteria in the gut, which is considered to be a healthy bacteria in the gut, and an association or a validation of causality with other diseases that heretofore, excuse me, we have not appreciated as being related to bacteria in our gut. So for example, there are data now suggesting that bacteria in our gut, so-called healthy bacteria, so far as we know, actually are causal or associated with autism, arthritis, allergy, asthma, autoimmune disease, and that's just the list starting with A. And it goes on and on. And so I think that's going to be a much more difficult problem for the regulatory agencies in the US, the FDA, to address and deal with, because what we're going to have to do is first validate that a given organism, a given bacterium, is in fact causal for these diseases or contribute to the causality of the disease, then eliminate it and show that in fact the disease is either prevented or it's improved or cured. That's difficult unless one is working with a very narrow spectrum targeted antibacterial agent. If one tries to do that with an antibiotic, any antibiotic, all of which are broad spectrum to some extent, it's going to be difficult to assess the long-term safety of that, as we are discovering, and a friend and colleague, Martin Blazer, has recently published a book on missing microbes. That is a real threat to the health of humans, and particularly children who are on antibiotics as their immunity system is developing. And so the long-term consequences there, even with narrow spectrum, one's going to have to monitor very carefully and decide, do you monitor for efficacy only on the course of the disease, or what other effects are there in the GI tract, particularly with broad spectrum agents that kill many bacteria in the gut. That I see as the most difficult regulatory problem. Avidbiotics specifically is avoiding broad spectrum, and in fact are focused only on laser-based killing, if you will, of the specific bacterium that we would like to, first of all, validate is causal by eliminating it and watching the lack of disease or the development or lack of development of the disease, and then show that, in fact, we can take it out without damaging the microbial community. That is going to be, we think, much easier. One of the reasons we have focused on, if you will, the laser antibacterial agent.